Welcome to the video. Oh, testing? Okay. Hello, welcome to the video. So this is an interesting example illustrating a way that statistics can sometimes be misused or misrepresented in workplaces or in the media. Hopefully after taking this class, you'll be equipped if you see them misused in this way to say, wait a second, I don't think that calculation was accurate. So let's take a look at a pretty common example of how a mean can sometimes be calculated incorrectly. We're looking at standardized test scores for a given city. And there's 3 schools in this city, and the mean test score, the average score for students at each school, varies by quite a bit. We can see at Lincoln High the scores were on the lower end at 72 as the average for the students there. At Central High, very high, the average student score was 90. Glenwood a little bit in the middle with the average school of 80. So the PR manager for the city just averaged these 3 numbers, added them up, divided by 3, and got 80.7 and said, that's the average score for our city. Hopefully, if you worked with this PR manager, you would say, wait a sec, we can't just average those test scores for each school, the school's average test scores, because each school has a different population of students. For example, Central City High had a lot more students than Lincoln. So Central City's average score of 90 should tell us more about the city's overall performance than Lincoln High's score of 155. So the way we can actually calculate an accurate average here is by weighting each of these average scores by the number of students who earned that score. So we can calculate the true average score as a fraction. In the numerator, we'll say, okay, there were 286 students who got an 80, had an average score of 80, plus 336 students who had an average score of 90, plus 155 students who had an average score of 72. So that's our numerator. That's in essence representing the total of all the students' scores in the city. And in the denominator, we'll put the total number of students in the city, which was 286 plus 336 plus 155. We add those together. If you go ahead and put all that numerator in the calculator, 286 times 80 plus 336 times 90 plus 155 times 72, you should get 64,280. So that's the sum of every student's score in the city. The denominator, the 286 plus the 336 plus the 155, gives me 777. So that's the number of students in the city. When I do that division, 64,280 divided by 777, the number I get is 82.728. So they want 2 decimal places, we'll round there to 82.73. So interesting to note that when we do this calculation in the correct way, it actually would make the PR manager's job easier because the average score is going up here due to the fact that more students were in the school with the average score of 90 than were in the school with the average score of 72. So the actual average score for the city is 82.73.